How many of you have opened the textbook? Wow, I was expecting less. Okay. How many of you have read chapter 15? How many of you have looked at the cover of chapter 15? Nice. Okay, that's it. I see. Okay. So, remind me when I get to like here, tell you what page. But I don't need it right now. Okay. Chapter 15 is adding stuff to benzene. Of course, that's not the real title, but that's what you're doing. So, this is benzene. Now we want to put stuff on it. So benzene itself doesn't really want to hang out with other stuff. But if we force it to, it will. So today, in your workshop you had this read. The one that you did already. You had number 4, if anyone cares. The one that's aromatics. Number 4, you had a mechanism. And they kind of just sneak it in there that it's the mechanism for alkylation of benzene. But most of you probably didn't read it. So you already have done this, and you just didn't know that it had a fancy name. So you can't say that it's hard. It's very good. So what we want to do, you have more guys' names. Right? I don't know if it's I-E or I-E.
E-L.
I-E, both? Okay. Not important. They're probably dead. It's okay. So you have alkylation, you have acylation. So you're aware they're going to have big A words. So, alkylation, we're going to take an alkyl group, which is carbon stuff, and we're going to make it go into benzene. Benzene, we're going to use a catalyst because benzene doesn't want to hang out with other things. Like that. So, first step, because of course we're going to do the mechanism. We have, he goes and be friends over there, and we end up with, oops, that's supposed to be nice. So they become friends. Then we take 1, 2, 3, and our chlorine left, so now we're sad. But this is what type of carbocation?
Primary.
Good or bad?
Bad.
Good. Well, bad, so correct. So we have a hydrogen jump over there. Arrow. And this guy's still here. And we end up with that, which is better. Then benzene comes back and he's like, fine, I'll hang out with you. Everyone loves benzene. We're going to come into our plus, of course. And so this is where people are like, chapter 15 is only one mechanism. But I'll tell you in a second, because I'm writing right now. Oh wait, that's sideways, isn't it? That's okay. Plus, he goes over there. So we know benzene's conjugated, so he wants to go back to being how he was. So if we make this bond, so I'm just connecting to the center. I know I moved to the right side, but it's okay. We have 1 hydrogen left, so he runs away and leaves his electrons here, and we fix benzene. Peter, you're making a squinty face.
Plus on the wrong person.
Where?
On the double bond.
Right.
Double bond, you need to put the plus on the very top.
Oh, sorry. I rotated it from how I found it. Let's do this.
Wait. Bottom part. Yeah.
Now it's here. Yes. Yes. Okay. That's hot. So, if we look, I kind of dropped the little red marker thing. So, if we look what we did, we had benzene. And then we forced something to look attractive to benzene. So benzene became its friend, but it broke its conjugation, so we put its conjugation back. And that's what we do every single time for all different things. So we want to make things look nice to benzene, and then we can put them on benzene, and then we do more stuff like that. So the important thing, if we always have the chlorine on the end, primary, it'll want to be secondary or maybe tertiary. It'll always want to rearrange, so you end up getting the V or like a W or whatever because of the rearrangement. And notice there's no chlorine in the product. The chlorine probably took your H away in the second last step. So don't put chlorines in your product. There's lots of chlorines to start. Don't draw chlorines on your benzene.
Who's the magic base on pulling away the H?
It's probably going to be your chlorine.
Ah. Got it.
This guy. When he's on here. Alright. Parallel to this, adjacent to this, we have their other magic reaction. Alright. So it's the same idea. So still have benzene, still antisocial, we still have a catalyst, we still have chlorines, but here we have the carbonyl. So put a nice star next to it. We have the same kind of mechanism. Oh, actually it's not, it doesn't look that similar. It actually looks really gross. Then benzene comes. And this is friend. And H hops back again. GG. Okay. Not yet. Okay? So that's our mechanism, that's acylation. So we got to this point, right? Did I use the same number? No, of course not. Okay. So we got to this point, right? So it's not really adding an alkyl group. I think you talked about this at the very end of the lecture. So you might not know what we're talking about. But if we want this to be an alkyl group instead, we go this, and that, some lots of dangerous things onto it, and we draw better benzenes. We get that. So we did it at the very end of our lecture. I know most people were backing up, but he was talking about it. So if you look, we added alkyl groups in both cases. At the very end, we added an extra step for the acylation, but don't bother. So everyone's right. Okay. So raise your hand if you like alkylation better. And you must have an opinion. And raise your hand if you like acylation better. Okay. So the thing is, we don't really want to do alkylation because it polyalkylates. It's the most ridiculous word I've ever said. So basically what it means is you might not get this product, you might get like a bunch of them on it. And if you only want one, you don't want this mutant guy. So with the acylation, so with the double bond O kind, you can add it with the carbonyl and then just do this last step and you'll get just one of whatever alkyl group. So the thing to notice is, like at this point, if I wanted one less carbon, I just draw one less carbon and I fix it for the whole time and I have one less carbon. So you kind of pick whatever alkyl group you want. So if you want 2 carbons or 3 carbons or 5 carbons or whatever, you just pick it. And when you go through the mechanism, obviously this will be 1 less the whole time. That's what you get. So it's awfully convenient, and then you just throw some mercury on it, and it makes it nice looking. Makes it the alkyl group you want. Opinions. Yeah.
That guy has a positive charge. The carbon
Yeah.
where the formation is happening.
Okay? So keep this in mind. Actively log this into your brain because you're going to be using it a lot. So we don't want to use this guy when we do synthesis because we don't know what he's going to do. Crazy. We want to use this guy because we know what we'll get. Okay? You have that one extra step, but at least you know what you're going to get. Oh, there's more knowledge on the back. Look at that. Alright, I don't need them right now. Okay, so let's bestow knowledge. I still need to do this. Okay, so if I'm on benzene, okay, there's this ortho, para, meta. It's really not that complicated. Directly across from the group that you're referring to is the power position. Next door to it is an ortho position, and the awkward guy in the middle is your meta position. So if I say ortho, para, meta, that's what I'm talking about. So it's in reference to whatever group I'm talking about. So it's not like the bottom one is para, because if I redraw it, and now I'm over here, this is para. Does that make sense? So directly across is para, directly next door is ortho, and the awkward one in between is meta. So that's just there. Okay. So at the beginning, I had written some words on the board, and one of them is activating / deactivating. That's 2 words. So it's mostly in chapter 15. You might not be that familiar with it yet, but it's on your test, so we're going to get familiar with it. Okay, so is everyone clear with the difference between an electron donating group and an electron withdrawing group? I feel so efficient. Does anyone want to tell me the difference?
An electron withdrawing group, you're basically vacuuming all of the electrons from the system towards the electronegative atom. And a donating group, you have an electronegative atom right next door to the system, and it's dumping its electrons into it.
Good. Okay. Perfect. So, when we're looking at donating and withdrawing, I have it nicely there. What we want to consider is basically if I'm the group, right? We want to know if I'm going to pull electrons towards myself or give electrons away to the rest of the compound. So, if we look at something like this, and I told you to draw resonance, what do? Like straight up resonance, plain old resonance. Make some sort of hand gesture. Yeah, that's the gesture. You go up. Okay? Are cool with that? Bonds are made of what? Electrons. I moved a bond up towards oxygen. So I moved electrons up towards oxygen, right? Everyone's good with that? Moving electrons. So if I'm the oxygen in the carbonyl, did I take electrons or give electrons away?
Take.
Take. So am I withdrawing or donating group?
Withdrawing.
Cool. What about this guy? Does he take electrons or give electrons?
Give.
Right. So he's going to take his lone pair and give them away. But lone pairs don't necessarily mean donating because he has, wait, where'd he go? He has lone pairs, but he's withdrawing, right? So you have to make sure you check because he can't go this way because we'd have way too many bonds on that carbon. So he has to go up. His electrons have to go up. This guy, if you put these electrons onto him, he would break the bond. We don't want to do that. So this guy's gonna give his electrons that way, so he's whichever way. So he's donating. Good so far? What about this guy? Donating? Withdrawing? Literally 5 people. Does someone want to tell me why he's donating or withdrawing? Does someone want to yell out a really long word?
Hyperconjugation.
Ah. Alright, so what we're talking about when we have hyperconjugation, we have our methyl. I'm referring to that methyl. And basically, when we're looking at these ones, we're talking about pi electrons moving around. So those are just kind of like resonancy ones. When we're talking about the methyl, we're taking this sigma bond, and he's kind of donating this way to like pi character. So he's giving his electrons from a sigma bond towards this way. Is it a dotted line or is it a real line?
I don't know what you're trying to do.
This guy.
You're not really drawing formal resonance structures. You're just making stuff up. But I mean,
That
it's
doesn't
true.
make me sound credible, Peter.
No. In the sense that I mean, hyperconjugation uses what we call so-called no-bond resonance structures.
Oh, that sounds less.
If you put a positive charge next to your methyl group, it'll make more sense.
This one.
In this first one, go one left, one carbon atom left. You put a positive charge there. Then you can put a formal pi bond there.
Okay,
Full
let's do
bond.
that.
Now, and then resonance arrow in the middle. There you go.
That looks good. Okay. Does everyone see where the electrons went?
Stabilizing the carbon cap.
Right. Does everyone see where they came from?
Hydrogen.
The electrons in the carbon-hydrogen bond, the sigma bond, are going to go this way, they're going to donate this way, and they're going to form this pi bond here. And the other H is hanging out nearby. The only difference between that and these guys is that one started from the sigma bonds, and this guy started from pi electrons. So that's why methyls are donating through hyperconjugation. So those are the only like weird ones that you can't kind of figure out from drawing it if you didn't know what hyperconjugation meant at all. So basically with donating and withdrawing, it's just if you're pushing electrons away from yourself or pulling them towards yourself. Okay? So those ones you can pretty much look at. Yeah.
If you're trying to figure out the stability of a compound with like cation, for example,
Mhm.
you have the donating group. Do you want the cation to be next, as close as to the?
You want to be able to draw the resonance so it fills in the charge. So
So I'm asking, is proximity more or better? Is proximity a more important fact than or is it?
I think if you can fill in the charge, I mean, if it's farther away, oh, that's a good point. If it's farther away, it won't feel it as much. So if I'm referring, like let's say this, if I'm referring to A, this guy we know is donating, and he's closer to that, so he's going to feel donating effect. So proximity, I'd say there is an important factor. So even though we have a withdrawing group there, and then as far as like,
But what if you
if
like?
it was like that, I don't think you would really feel it.
But what if you like a conjugated system and you kind of like?
Yeah, well then you can draw it out all the way through.
Right.
So
In
then
that case.
in that case, yeah, exactly. So also write that down. This guy, depending on which side you're talking about, you're gonna feel either withdrawing or donating. So if I'm A, I feel donating. If I'm at B, I feel withdrawing because I'm closer to whichever. Okay? So it's not one or the other. It depends which side you're on. Which one? Here, there's one. Here, there's one. Yeah. Okay? Alright. So now, back to activating and deactivating. So if I have a donating group, okay, on a benzene, going to activate the ring. With drawing group deactivate the ring, because we're opposite. Okay, so if I activate a ring, that means it's going to react more quickly. So it's the same kind of thought as when we put donating withdrawing groups for Gilvaler. Okay? It's going to make them react more quickly. So when we put withdrawing groups or donating groups onto benzene, it makes it more reactive. Okay? So if we have a donating group, it's going to, they're called directors. So they direct things. They tell people what to do. So if you have a donating group, it's going to direct ortho-para. So there's a group of things, and they're called ortho-para directors. So what it means is, if I have a donating group here, okay, so before it was my name, so now it's a donating group, any whatever it is. If I try to add something onto that, it's going to go either ortho or para, and para is preferred. So whatever group I add on is going to go there, because it's an ortho-para director. If I try to add another group, it can't go to the para position because there's already something in the para position. So then it goes to ortho, which is less preferable, but since this is full, it goes to that one. So it doesn't matter which one, all the numbers. Withdrawing groups are meta directors, right? So they're all completely opposite. So there's another group, and they're meta directors. So if I have a withdrawing group, it'll direct to the meta position. So if I have this and I add something onto it, it'll end up in that position. Or the left, it doesn't matter because it's symmetrical at that point.
If you have two molar equivalents, would it then add on the other side? For
For two molar
ortho and meta?
I think it would just add to another benzene.
Well, if you had twice as many equivalents of your electrophiles
Oh.
as you do benzene,
Yeah.
then you probably get twice. Yeah.
So,
Okay, and then same thing here. These guys are equivalent, so it'll pick its side. Okay? Good so far? So now for the page number. So if you have the textbook, I think mine's the 10th edition. It's relatively recent. So on page 696, and it's 19remember, there's a magic table that has them organized for you already. So you can just write it out yourself and put your donating groups in one side and your ortho-para. Yeah. Ortho. Okay. Or you can just copy the next table. The only weird one is halogens. So basically what it's saying is all of the activating groups are ortho-para directors. So they're on one side, and then all the deactivating groups are meta directors, so they're on the other side. The only weird ones are the halogens are weakly deactivating, but they're ortho-para directors. Okay? So, I don't know off the top of my head. 696, but no. So, literally, it's like a teacher. You have strongly activating here and strongly deactivating on that side. So it goes like this and then like this. Okay? So this is the important part. So if you're asleep, wake up. When we start a problem like this, we start with benzene. Whatever our first group that we put on, we use that group, whatever directing it is, we use that when we put our next group on. Once we have more than one group on, we have to pick which one to take directions from, right? So, strongly, whichever is the most strongly activating group, that's who you listen to. So if you have a group on the table that's like right here, that's who you listen to. If it's between this guy and this guy, so A and B, you listen to A. He's more strongly activating, he takes charge, and he tells you where to put the next one, so the third group. If it's between A and B, so I should use the line, A and C, you still listen to A. You still direct with respect to A, okay? If it's between C and B, who do you listen to?
C.
C, okay? Whichever one is closest here, you listen to. So like your halogens are on the bottom here because they're ortho power directors, but they're weakly deactivated. So if it's between a halogen and C, you listen to C. If it's between a halogen and B, you listen to the halogen. Okay? So, and it has them like strongly activating, moderately activating, weakly activating. So they're grouped for you perfectly. So you're just going to pay attention what type of group you're dealing with. So once you have the group on there, 2 groups on there, you have to see which is more strongly activating. So when you put your next group on, it has to be in reference to that. This is very important because you're going to have a lot of questions where it's benzene, and there's already, and it's like that. And they want to know how you got to that point, starting from benzene. So you have to either go backwards and figure it out, or start from benzene and go forwards to that. The most important part when you're doing this is the order that you put the groups on. Because if you put A on first, it depends. I mean, I'm not going to go through, but it depends. The order will determine your product. So if you're not paying attention and you put it on and it's a meta director, but you know it needs to be in the other position, you can't just decide that. So then you have to rearrange your order. Okay? And there will always be an order that works out. Sometimes it's really frustrating. So on that, did you have a question?
Yeah.
Okay, go.
So, based on that chart,
Yeah.
so if you had to decide between a weak activator and a strong, a weak power director and a stronger meta director.
No.
I mean, weaker meta director. So you decide.
You would always take the closest one here. So basically, you have strong activators, you have moderately activating, you have weak activating, weak deactivating, and those are the halogens. So they're in the left side, they're deactivators. And then you have more weak deactivators, mod deactivators, and strong deactivators. You listen to whichever one's the furthest left. So even if it's a strong deactivator or versus a weak activator, strong and weak doesn't matter. It's
Right.
closest to the strongest activator.
Right,
So if it's
okay.
strongly deactivating, it's the farthest from activating. If you have the only thing on your benzene is a strong deactivator, then you listen to him because there's no one else. But other than that, you really won't take directions from them.
So you only take directions from deactivators when there's
You
literally
take
no
the
one else.
direction from whichever is the most strongly activating. So it's different for each time you do a question. Does that make sense?
Yeah.
So you have to look each time what groups you're dealing with and figure out which one to listen to. Okay. So let's say, so we know para is preferable to ortho. So directly across is preferable to next door. We don't really want them that close to us. We want our personal space. So let's say, for some reason, I want this. So they're what to each other? Good, perfect. They're ortho to each other. Now let's say A is an ortho para director. If I start with benzene, for the much better benzene, and I put A onto it, okay? If I try to put B onto that, will I get that product?
Oh no. We get that.
If A is an ortho para director,
No.
will I get what I have drawn?
No.
No. Okay. My product would look like that. But that's not what I want, right? So the question is, how do I get it? basically what I do from here is I'm going to take a big stop sign and I'm going to be like, no. So he gets directed para. Now the para position is full, so if I add a group at this point, A, let's say strongly activating, what position will B go into?
Ortho.
Good. Does everyone follow that so far? Now I just take no off. No, no. Does everyone follow my very first example? Good. Now I'll fill it in with something real. Can you read over here? Is the podium thing in the way? Yeah, okay. And this guy is called whoop. If I want to force something to be ortho, if I want to force it into the less preferable location, I just put something else there, make him go in the other position, and then take the first thing off. And that's how you do it. Yep.
Wait, why wouldn't B come off? Or
Why went into what?
B come off? You
Come
thought
off?
we- Yeah, like instead of the SO2.
Ah, because when, I don't know, when you go through this, you will, actually you did this in class today.
We did it in class today. We're doing it in class next week in workshop.
Oh, well, they doesn't look exactly like
Did you
it.
walk group in class today?
Oh, maybe they did, something. They did something look like this.
We had
Maybe they
benzene
added the
sulfate.
S.
You put the nitro on. You put the nitro on today. NO2?
There were definitely some sulfurs in there.
There was sulfonation.
SO who? SO2?
SO3.
Are we throwing words out now?
Yeah. Yeah, it did.
So,
Oh, they did do this. Okay, doesn't matter. You have to do it anyway.
never.
Sorry, what? Repeating? Yeah. Okay, so if I have benzene and I put A on, so A is my only group, right? So I have to listen to him. Let's say A is strongly activating. That makes it orthopara. Whatever A is, I don't care. That means para is more preferable, so whatever thing I put on next is going to go para. But I want this product. I want B to be ortho. Ortho is less preferable. It will go to para first. That's more preferable. So what I do is I take this blocking group, put him on first, so he'll get directed there. Then add B. B can't go in para because it's already taken. He's forced into the ortho position, and then I take him off, and everything else stays the same. So he's forced into the ortho position. So if you wanted to go into the ortho position, you have to make it go. Para is more preferable. So that's why it'll add here automatically. But since we don't want that to happen, we make something else add there, and then we get rid of it. Questions with that? No? All right. I should think you guys can't do a question unless I give you the chart. Make sure you write down the page number with the magic chart. So other than that, when you're adding all these different groups onto benzene, what we mean when we say that it's the same mechanism because you're pretty much the same kind of deal every single time. The important thing is the order. So it's really not that hard chemistry. It's more hard like puzzling. I need to give you can practice. So you don't need to write it down, just use it. I don't think you're really good. Okay, I think that's all you need for the one. Okay, so when you're doing these questions, you want to, if I give you a product, let's say, you have to figure out what's the most important as far as directing. Because you have to make sure when you're going forwards, right, your order makes sense as far as who you're listening to directing. So even if like, oh, this one's a meta directory, so, and it's in the meta position, so that's cool. But if you had a more strongly activating group, you wouldn't listen to that meta director, you would listen to probably the power director. So it's really just figuring out the order. The one thing, other thing, I said the page thing, right? I told you the page. The only other thing you need, the only other thing I think you need is actually what's on the sheet. With something like, right, so when we did our isolation before, right, when we had the double bondo, we took it off. If we look, when we have our double bondo, it's a meta director. So I can use, not that one, the other one that's here. I can use that, put it on benzene, and it'll give me some sort of carbonyl piece, carbonyl alkyl piece, okay? That's meta directing. This is how you get questions right because this is how you cheat the system. Listen. So if you use the acylation and you can put on a piece like this, right, with the double bondo, so whatever it is, double bondo with stuff, okay? That's a meta director. Once you do the mercury and zinc and you get rid of this, he's an alkyl group. He's an ortho power director. Use that to your advantage. If a piece is in the wrong spot with what you have, change the piece. Okay? So keep that in mind going forward. If you need something to be, there's not that much many meta directing pieces. If you need it to be meta, leave the double bondo on. And then in your product, if you do the alkyl piece, take it off at the end. It'll just take the carbonyl off. Other than that, if you want it to be orthopower, make it the alkyl first, and then put your other group on. Does that make sense? So depending on if you use, once it's like this is meta. Once I take it off, whatever it is, this is orthopower. Use that to your advantage. If something's in the wrong place, you probably need to do something like that. That's how you get around it. Okay? So if we were to look at, oh goodness. Oh, the other thing you should know, which you did do, CL2, that'll just add it onto it. So that's helpful. But you did that already. So the AlCl3 is just a catalyst because benzene's stubborn. So let's do a practice problem. This is super easy. I write this on the board. And again, this is in your book, so don't waste time with copying. I'm not going through all the individual mechanisms because they're almost identical. And it's literally just, this is how you put this group on, this is how you put this group on, this is how you put this group on, and it's just different letters every time. What's the product? Draw it. And I'll give you a hint, it drops an O. And then you sure I do want that. 5 minutes we would come up.
So we dropped the number, so it has to be NO2. NO2 is going to be on the meta position. And we have basically working with two meta.
Where?
Second problem.
803 from the top. Hmm?
So you're having under it's OR,
What?
left, up, there.
Here.
Yeah, it's OR, and
Yeah.
then for the meta, you drew it as just carbon chain.
Yeah. Yeah, that's what it is.
Is there an O there though? Is it an oxygen?
No, it's just squiggly lines. It's just whatever alkyl piece it is. So it can be like,
Okay.
that makes sense? Whatever number of carbons it
Oh,
is.
Gotcha.
this is. Yeah. This is what she was referring to. This. She was
This?
using full difference. Like this is what she showed us, and this is what.
It's literally in your textbook and it's color coded.
Yeah. So like she's right both ways, but like if we didn't look at this, we would assume.
But if you don't carry your textbook around, everyone doesn't.
Exactly. 696. 696. Do you have 11? Because this is 10. Jen, page 696. That only refers to the 10th edition.
Yeah, but that's the most recent one, isn't it?
No, there's up to 11.
Aren't you supposed to have 10 though? Or you have 11? Oh. I don't know if he does in your book.
I'll link the picture with the video.
Cool. She got this.
6, 8, 9, 10.
Actually, very strong.
Are we done with those problems? Let's go over them. Raise your hand if you're done. Raise your hand if you're talking and you didn't do the problem.
What if like
Try it yourself. I mean, you can work with a friend, but I mean, don't wait for me to do it.
If I'm wrong, I don't know. I don't know.
There is no particular order. I don't even know what it stands for. HNO3 and H2SO4. Okay. Why is this one so long? What letter? Okay. Try these and then we'll go over them and I'll make sure you don't miss the tricks and secrets. They're not so secret. I just want to.
You don't put SO2.
Where?
No, well, you put NO2.
BR2 after BR3 and then 11. I'm gonna go over them, so make sure you try them.
It's because she had
Oh, I'm gonna go over them. Make sure you try them. Okay, I'll just go right over them.
yes, it's stronger deactivator. Yes. No, right side.
Did I do that? Sorry. Hold on.
Remember that little. So whoever's the stronger activator you listen to. In that case, the broom, like, okay. Did you finish the left problem, A, B, and C? So you put this, so you listen together.
Let's try not to break this.
Did you do A? So, despite it being a weak deactivator, still considered an overpowered direction.
Yes!
Yeah. 369. Wait, 669. No. 669. Okay, so B. So, despite it
That's not the one for your textbook, but it says the same stuff.
BR. Despite it being a weakly activated, it's a donor, therefore.
Oh, so it's gonna go para.
Who's gonna go para?
Why do you assume I want you?
And the next step is basically get rid of the bond program. And that's it.
What time is it? Actually, I have a clock now. Never mind.
Lowest, 21 on February
5 more minutes.
Of the oxygen here.
Always check your thing going forward.
But I don't know the Xan name. as simple as that.
Who only has one question left? Raise your hand. Who has 2 questions left? Who has 3 questions left? Who actually did the questions? That's not good. Yeah, I put one more. I'll write it on the other side. It's 2 more.
Where's that?
Yes. Yes.
Wow, I didn't even know that. Wow, that's crazy. Okay. What? I can't see that.
Eddie, could you take over this until I get back? I'm gonna go for like 2 minutes of that.
Okay. I'll just move it slightly.
Yeah, how much motivation
Yeah,
do you think,
I'll just focus on her, right?
yeah. This is zoom in and out. I'll be right back.
You can go through there. Just 4. Oh, I see how she has it. Okay.
Good? Is that like good or is that like? So there's 5 questions on the board. Number 5 is up there twice because the board's so long.
I can't see 5, and I can't see 4, but I can't see.
I pressed that. What it did. Really bad. Climate, there's a climate button. I don't know, I don't want to mess it up.
It adds ambience.
Maybe I can control the snow.
Can you make it like so we don't have class? Please? Like the delay doesn't bother me, like it doesn't affect me at all.
It affects me entirely.
It doesn't affect me at all. Like my day starts at 1, so
My day ends.
I know. So sucks to be me. Be a bum
3 minutes, I
tomorrow.
will go over them.
And I really
That's
hope that they
9:30.
like, just cancel it. Straight up cancel. And miss out on genetics? Are you fucking me? Okay. When did your day start?
Are you playing that game, Peter? I swear to God.
So, here, Jesus. What's the class about? You had what? How are you? Is that really hard to Wait. You live around here or I'm from White Plains, which is like literally Prasad over there, this kid, he commutes with I still don't know how he does it. Yeah, she lives 15 minutes away.
Thank you for guarding it.
Yeah, we're just talking about like, you're a commuter?
Yeah.
How far away do you live?
45 to an hour.
And is it worth it, like just commuting like that every day or whenever you have class?
I don't have to take on debt. I go to school for free now. It was awesome. Like, I had college for like that first grade. And I think it was like because I got to like stay here for all these revisions or hang around with friends and not go to bed until 5 a.m. Well, that's why you hate your dorm.
Yeah. Well,
Move to like a decent quad, like 8 or Mendelssohn's bus. It's convenient ever. It's really like the best.
Yes, okay.
Love like coming into the pool. You can do physics and whatever.
I'm going to try to leave one of these songs. Get rid of one so I can find it. Alright, that one. Okay. Cool. So. Alright. So, number 1, I think is the first one I put up. So, it might have been confusing. When I'm talking about directors, okay, it's whatever's already on your ring. So from that point forward. So the things on the ring is going to be your director, and whatever you're adding is going to be direct 10, okay? So on the ring, if you have more than one group, you have to decide between those two groups, which is more strongly activating, okay? And remember, if it's more strongly activated, it's more reactive. That was the sentence. Keep that in mind. All right. So, on this bromine, I have 2 groups. I have a methyl and I have a 3-1. So, which of those, you can see all over there, if you wrote it down, is more strongly activating? Anyone? Okay. I don't think so. We have, not here anymore, under moderately, well this is green, we have OR, and under, this is activating. Weakly we have R. Which is more strong? I think it's on this big one. Yeah, you see how, can you see if I can do this? Yeah. You see here, on the big thing? Oh, alright, anyway. So, we look over here, this guy. You can look on that one. That's OR. That guy. Over here we have just plain R. And so R they put in weakly activating, or it's kind of, I mean it's pretty strongly moderately, is the word. So I'll redraw it here, because I'm left with it. So we had what, methyl and that. So this guy's more strongly activating, right? Is he donating or withdrawing? Donating. Is he activating or deactivating? Is he activating or deactivating? So is he ortho para or meta? Ortho para, right? Donating groups are activating groups are ortho para directors. So this guy is more strongly activating, so he's the important you listen to. So this one, you're going to follow his direction. So he's already para. Para you'll always go to first. In this case, para's already taken by the methyl. So I go to ortho. So what was I supposed to add? The NO3, right? No. Was it? All right, let's do that. So we put, we put him in this position. Cool? The chart in your book is a lot nicer than this chart, but that's the agreement. So let's put this guy back up. We'll do number 2. So does that make sense? You just have to look on, basically look on the chart.